we just gonna do a recap on what we started yesterday. So real quick, before we start with activity 3, what do you guys remember from yesterday? If you do remember something. If not, that's okay. What are we doing on the lesson? David, talk to me.
Yesterday we learned about the parallelogram / congruent parallel side theorem.
Okay. What do we say about that? In your own words. You don't have to read it. If you remember something, you don't. Then read it.
If one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram.
Okay, good. Do we write a converse for that definition or no? We did. Some people did. I asked if you guys want to write a converse since it's given to you as a conditional statement. So if opposite sides are both parallel and congruent, the figure that you're looking at is a parallelogram. That's all it says. So today we're going to continue with properties of more quadrilaterals, specifically trapezoids. Anybody in the mood to read trapezoids? Jen?
A trapezoid is a quadrilateral with at least one pair of parallel sides. When a trapezoid has exactly one pair of parallel sides, the parallel sides are the bases and its non-parallel sides are the base. The base angles of a trapezoid are either a pair of angles that share a base as a common side. Recall that an isosceles trapezoid is a trapezoid with congruent non-parallel sides. You conjecture that the base angles of an isosceles trapezoid are congruent.
Okay, good. So this talks about trapezoids in general. So notice that we're not talking specifically about isosceles trapezoid, where your non-parallel sides, aka the legs, are congruent, or we're not talking about a right trapezoid that has a leg perpendicular to both of the parallel bases, right? Parallel sides, also known as the bases. So this talks about trapezoids in general. Is that a beer? Why is she so loud? Okay. Jeez. So here you guys have a worked example on how to prove that the base angles of a trapezoid are congruent. And I really hate the fact that it's a worked example because you already have that there. And since the work is entirely done for you, you're probably like, no, I need to read that. So you have all your statements and reasons, and I get that. But notice that for this particular proof, you guys are doing some constructions that have to do with the definition that we just talked about. So this is supposed to be a question on a textbook because they ask you, what do you think is the importance of doing something like that? So that's the second step when you guys are constructing a line PZ that is parallel to RA, right? Once again, I gotta ask this question because why not? Every time you guys know information about parallel lines, what are you thinking about? Line such and such is parallel to line such and such. That's a hint for you to talk about
corresponding angles.
Corresponding angles. Corresponding angles only?
The corresponding angle theorems.
Corresponding angle theorem. Interior angle theorem. Exterior angle. Go ahead. Angle relationship, right? In general, angle relationship. I know that there's a certain angle relationship that holds true if and only if they're formed between parallel lines, right? So I cannot say, oh, corresponding angles are congruent just because they're corresponding angles. But if I have corresponding angles that are formed between parallel lines, then I could say these corresponding angles are congruent according to the corresponding angle theorem that says if two lines are parallel cut by transversal corresponding angles such as such and such and such and such are congruent. So that is the case. So anything else? As a result of that construction, is there anything else in there? You could probably break down the 3. So maybe that will give you an idea of why are we doing this construction. See, the goal is to prove that this guy over here is congruent to this guy over here. But you see everything we're doing to make that happen? So first we're saying trap is an isosceles trapezoid. That means if it's an isosceles trapezoid, I have TR and PA parallel. How do I call the parallel sides? This is so
Good
bad.
morning. Part of the interruption, can I please have the students who are missing their Krispy Kreme orders to the main office, please? The available students who are missing their Krispy Kreme orders to the main office, please. Thank you.
This is going on YouTube. Such a nice commercial. We better get paid by Krispy Kreme for this ad. So, how do I call the parallel parallel sides of an isosceles trapezoid
The base?
base. And then they say TP is congruent to R8. How do I call line segments TP and R8 on an isosceles trapezoid? Mauricio?
The light.
The legs, you see? Alright, beautiful. So that's given information, and then it's obviously a construction that you guys are doing. The idea behind the construction is, like we said, if we have a pair of parallel sides, we can talk about angle relationship, but we could just use the definition we just talked about. So if we look at ZRAP, it's a parallelogram. How do I know that ZRAP is a parallelogram? How do I know that? Don't say definition of parallelogram. Is that what you guys think? John?
Because ZP is parallel to RA.
And?
Opposite.
And? Congruent. So if I have a pair of opposite sides that are both, we just said that, right? So if I have a pair of opposite sides that are both parallel and congruent, then the figure that I'm looking at is a parallelogram. Boom. Easy. So now I have the opposite sides in a parallelogram are congruent. And since that's the case, and I'm saying that ZP is congruent to R8, I know that CP is also, I know that TP is also congruent to R8. So if TP is congruent to R8 and ZP is also congruent to R8 by transitive property, TP is congruent to ZP. You see that? So TP is congruent to ZP. So if these two sides are congruent, I know that. So these two are congruent because they're opposite sides of a parallelogram. These two are congruent because they're the given congruent legs on a trapezoid. And now by transitive property, I can say that these two are congruent. So if these two sides are congruent, what type of triangle is triangle TPZ?
Isosceles.
Isosceles. And how do you know that? Just for the record.
They have two congruent sides.
Okay, I have the two congruent sides over here, so I know that TPC is an isosceles triangle. What's the base of my isosceles triangle? What's the base of isosceles triangle TPC? Zayden?
TZ.
TZ. Alright? Okay, so, and since I'm so good and I know about the base angle theorem of isosceles triangle base angle theorem, I can now say that angle T is congruent to angle TZP. See it? Now I can say that these two angles are congruent because of isosceles triangle base angle theorem. So opposite to those congruent sides on an isosceles triangle, you have congruent angles. Next, I'm saying angles TZP. Angles TZP and angle R are corresponding angles. So if you're looking at the two parallel lines cut by the beautiful transversal over there, you can tell that they are corresponding angles. And since the lines are parallel, because you created a beautiful parallelogram, since the lines are parallel, corresponding angles are congruent. So with that being said, if these two are congruent because they're corresponding angles, and these two are congruent because they're base angles of an isosceles triangle, that makes angles T and R congruent by transitive property. We good? So everybody following along with the proof and makes sense now? I know it's a given, but sometimes you have to train your eye and how to read between the lines, because I know it's boring when you just like go through the entire thing and it's a whole bunch of nonsense until you make sense of it. Boom, boom, boom. So that was that. Now we have to do a short proof on. So how can I prove now that trapezoid? The diagonals of my trapezoid are congruent. So I'm trying to prove that TA and RP are congruent. How do I make that happen? If I'm given that my figure TRAP is a trapezoid, and my trapezoid has sides TP and RA parallel to each other. So TP and RA are parallel to each other, but I also know that TR is congruent to PA. I also know that TR is congruent to PA. And I'm going to ask you if you guys have a plan or an idea of how do I make this happen. So how do I prove that TA is in fact congruent to PR. How do I prove that the diagonals of my isosceles trapezoid are congruent? Hey,
we can prove that triangle TRA and TRP are congruent.
triangles TRA and
They're TRP
RP.
or RP. It's the same thing.
Say it again. So TRA, triangle TRA, this one over here
Yep.
is congruent to
TRP. RAP.
RAP, this one over here. Why am I thinking about these two triangles over here? Why am I thinking about the two triangles over there? See if I could do a better one for whoever's gonna watch this later, which I don't even know who's gonna watch this later.
Because they're one of their lines,
Because of what?
because the diagonal is one of the sides.
Okay, the diagonals are actually they showed up on the side. So the diagonals of the triangles that you're talking about, the diagonals of trapezoid, both sides of the triangles that you're talking about. So yeah, that's the reason why we choose in, let's say these two triangles over here. Now the question is, can you guys find a way to prove that these two triangles over here are in fact congruent triangles? Ta-da! What's that? There's obviously a way. Who has it? What all right? John, talk to me.
You could use reflexive property to say that RA is congruent to itself.
Okay, before I said that, do you want to say something else? Like any given information that you like to use before I put I go into the heavy duty stuff?
TR is congruent to AP.
Okay, so I'm gonna write down that TRAP is a trapezoid. And that is given because that will allow me to use any of the properties of a trapezoid that I could possibly know. So anything regarding properties of trapezoids that I could think of, I'm allowed to use it on my proof because they gave me that the figure is a trapezoid. So they didn't say the figure is a quadrilateral. They didn't say that. They were very specific. They say the figure is a trapezoid, which means all properties that you could possibly know of trapezoids, you're allowed to use. So we have that information. So we start with the fact that TRAP is a trapezoid, and that is given. And now you guys like to say TR and PA are congruent. TR, line segment TR, is congruent to line segment PA. And what is that? Why are they congruent? Hillary? Given? Yeah, definition of a trapezoid. You guys can either say definition of trapezoid, definition of trapezoid, or you could say, opposite legs of an isosceles trapezoid. Whatever you guys like. But yeah, in a sense, it's given. It's part of the properties of trapezoid. So, that's how you know that. What else do you know? So we have the TR and PA are congruent. So we have that TR and PA are congruent. What else do you know? Zayden.
That TA is congruent to itself.
TA as in like this one right here?
Yeah.
That's the one that we're trying to prove congruent with RP. TA and RP, we're trying to prove that TA and RP are congruent. I could definitely say that, but I don't know if that's going to help me in my proof. There's something that I could say around those lines that could actually help me with the proof. Did you see it?
RA is congruent to itself.
Okay, that one I could definitely use. So I could use the fact that I could use the fact that line segment RA is congruent to itself. And why is that? Why is RA congruent to itself? I'm with you. Reflexive property. So So that is reflexive property congruence. So I got that. So far I have two sides. I have two pairs of congruent, two pairs of sides congruent to corresponding to sides of another triangle. What else would I need? What else would I need to make that happen? Hillary? Not sure. Anybody? Eli?
Angles R and then goes A.
Okay, I'm going to use 3 letters. I like that. I'm going to use 3 letters in this case, so you guys can see that I'm talking about this entire angle over here, and I'm talking about this entire angle over here, and in fact, they are congruent because you guys have information on that figure. Like I said, it's not a quadrilateral. It's not a random quadrilateral. They specifically say the figure is a trapezoid, right? So I'm going to say angle TRA. TRA is congruent to angle PAR. PAR. And why is it that they're congruent?
Definition of a trapezoid.
You could say that, or you could say they are, what type of angles they are in a trapezoid?
Adjacent.
Hmm?
Adjacent.
Adjacent.
Base.
Base.
Base angles. So they are base angles of a trapezoid, right? Should say isosceles trapezoid. So they are base angles in an isosceles trapezoid. Do I have enough information to conclude that these triangles are congruent by either one of my definitions?
Yes.
Yes.
I'm pointing up there like they could see out there. Hillary.
They're congruent by SAS.
Okay, so I'm gonna say triangle TRA.
And R.
TRA congruent to triangle PAR, and they are congruent by
SAS.
SAA. I meant SAS. Boom. Okay. What's the whole purpose of doing that? Because they didn't ask me to prove if the triangles are congruent or not. They asked me to prove if TA is congruent to PR. So what was the whole purpose of doing something like this? Angel?
That means TA is going to PR because of CPTV.
CBCTC? Alright, beautiful. So now that I proved the triangles are congruent, I could say that every other corresponding part that is left, that I didn't use on my proof, so every other corresponding part of a 2-figure, it's also congruent. So now I could easily say that TA is in fact congruent to PR, and that is by CPCTC. That stands for corresponding parts of congruent triangles are congruent. Questions? Questions? No? Okay, so I'll wait for you guys if you need to take any notes. And the last notes you have to take, please do that. But that would conclude the proof. It wasn't that bad. Alright. Who am I waiting for?
Eric.
Okay. So at least I have an idea. Let me know when you guys are done. That's good. He's counting on everything. Oh, sorry. So you guys had a proof on this. We're just giving a proof. It's the trapezoid mid-segment theorem. I know you don't have this on your textbook, so I gave you a visual so you guys could see it, right? So it says trapezoid mid-segment theorem. It says that the length of a mid-segment of a trapezoid is equal to the average between the bases. So sum of the bases divided by 2. Sum of the length of the bases. The length of one base is 8. The length of the second base is C. So the length of the mid-segment of a trapezoid is given by the sum of the two bases divided by 2. It's the average between the bases. So from this slide, the only thing that you guys really need is the diagram, which you guys have it down. And then another thing that you probably, you might want to notice on the figure is that if you look at the two legs, I am not giving you an isosceles trapezoid. So I'm not saying that the legs are congruent. I'm just saying this point right here is the midpoint of this leg, just like this point right here is the midpoint of this leg. So the distance here are the same. The distances here are also the same, but the two legs are not necessarily the same length, right? This applies for trapezoids in general, not only for isosceles trapezoids or not only for right trapezoids, so it applies to any trapezoid. All right, everybody good with that? All right. So, properties of kites. Anyone else in the mood to read? Hillary, talk to me.
Properties of kites. Recall the conjectures you have made about kites. A kite is a quadrilateral with two pairs of congruent adjacent sides. When a kite is not a parallelogram, it has its own properties. Only consider kite KITE with diagonals, line segment KT, and line segment IE. Only one pair of opposite angles are congruent. It is the pair of angles formed by the non-congruent sides. So, angle KIT is congruent to angle KET. Only one diagonal bisects the other. The diagonal that is bisected connects the vertices of the congruent angles, so line segment IS is congruent to line segment ES. The other diagonal bisects the opposite vertex angles it connects. So angle IKS is congruent to angle EKS, and angle ITS is congruent to angle ETS.
Alright, so I tried my best to do the markings on the figure that you probably need, just to give you an idea on properties of kites. But this is something that we already talked about, so I'm not trying to spend a lot of time on this. If you have any questions, we'll talk about that later. Alright, so using properties now to solve problems, so I'm just going to jump to activity 5. So we're going to try to use whatever we learned throughout this lesson to solve problems. Anybody reading this? Melanie.
Using properties to solve problems. Use what you know about properties of quadrilaterals to solve each problem. Ophelia is making a square mat for a picture frame. How can she make sure? What does it say?
How can you make sure that the mat is
a square using only a ruler?
okay? How do I make sure that my mat is a square using only a ruler? You have ideas?
That you can make sure like all the sides are congruent. And like with the edges of it, you can make sure it's perpendicular.
Okay. Sebastian? Make sure the diagonals are congruent. So with the ruler, I can measure the diagonals, and my two diagonals have to be congruent. What else? For the quadrilateral to be a square.
All the sides are congruent.
Okay. What else?
That has two diagonals.
It has two diagonals. All quadrilaterals have two diagonals before a square. If I need to make sure that my mat is a square mat, and I'm using only a ruler, I can measure my four sides. Hear me out. I can measure my four sides, and my four sides to be congruent, but what other quadrilateral has all four congruent sides? What other quadrilateral has all four sides congruent? A rhombus does, right? So how do I make sure that my mat is a square, even though it has all four congruent sides? How do I make sure that my mat is a square and not a rhombus? You see what I'm saying? How do I make sure that it's a square, not a rhombus? I have a ruler.
If the diagonals are perpendicular and congruent,
The diagonals need to be perpendicular and they need to be congruent. So you want one diagonal like this, and then the other diagonal like this, right? So they're both perpendicular and they're the same length. Is that good?
No.
No. So this will give you a square, right? So if this is one of your diagonals and this is the other one of your diagonals, they're both congruent, right? They're both congruent
Yeah.
and they're perpendicular. Is that giving you a square?
No,
Aiden.
they bisect.
Okay, so now we're talking. Only one bisects the other, like on my beautiful kite, where only one diagonal bisects the
They
second
bisect
one.
each other.
They bisect each other. So you want to make sure that the diagonals are the same length, right? The diagonals are the same length, but they bisect each other. So if the diagonals have the same length and they bisect each other, and they are the perpendicular bisector of each other, right? So if the diagonals are congruent and they are the perpendicular bisector of each other, then in that case, when you connect the sides, that will guarantee for all your four sides to be congruent because you'll have a square. Obviously, that's a sketch.
Bless you.
Just gave you a general idea. So don't judge my picture. What else do we have here? Okay. This is activity 5, so we'll probably. So what I'll do now is, for the purpose of the video that we're recording, I'm just gonna tell you the activities that we're working on, so you can circle the activities, and then we're gonna pause it. So it's activity 2. I don't know if you guys want to circle that. So we're gonna be working on that problem. Activity 2. You ready? Just circle activity 2. And then we're gonna go to activity 3. I'm obviously there because why not? Yeah. So activity 2, activity 3, obviously A and B. Alright. So we just circle that. And then it's just a talk. Oh, which I haven't seen there because yeah, why not? So it's activity. Once again, it's activity 2, activity 3, and then we're just gonna go into the talk, and that'll be the end of this lesson. All right. So if we could pause it.